these are packages you use?
Yeah. Awesome. Like, is everyone having a good time till now? All right. So, hi, I'm Vinayak Mehta. You can follow me on Twitter here if you like. Yeah, that's a secret I'll take to the grave. Just kidding. Can discuss it offline. I work as a data engineer here at Grofers. If you want to learn more about what kind of problems I work on, you can we were already discussing those problems, so we can just chat later. So in this talk, uh, in this in this talk, I'll be talking about mostly how you can extract tabular data from PDF files using Camelot and Excalibur, which are two Python packages that I developed. I'll start with giving a general history of the PDF. Um, then I'll move on to the problems I faced while extracting tabular data from a PDF, and then I'll show you some code on how you can do it easily using the packages I mentioned. So let's begin with a fun fact. Does anyone know why Python is called Python? Yeah, correct. While he was implementing Python, Guido van Rossum was also reading scripts from Monty Python's Flying Circus, which is a BBC comedy series from the 70s. And he wanted something that was short, unique, and just short and unique, and that's why he named the language Python. I guess.
Who is better than?
So yeah, I guess every one of us has interacted with a PDF document at some point in our lives. Does anyone know what PDF stands for?
Portable document format.
Yeah, I guess I showed you that already.
That's a big deal. Big deal.
Yeah. So let's go through the history of this format. This was an internal memo published by Jay Warnock, the co-founder of Adobe. When basically he proposed that we want some kind of a format which we can share across operating systems, communication networks, and different system configurations. The goal was to make the documents viewable on any display and printable on any modern printer, and hence the portable document format, because you can port it to different systems.
A very nerdy kind of thing.
Yeah. So it was built on top of PostScript, which was already present. It was a page description language that had solved this view and print anywhere problem. A PDF document encapsulates components that are required to build a document, like text, vector graphics, images. It also defines specific instructions on how to place those components at precise XY coordinates relative to the bottom left corner of your page. So you can see that words are simulated by placing some characters closer together, and sentences are simulated by placing words relatively far apart. So we'll come back to this image in a while. But you guys must be wondering what's up with this guy? Why is he so obsessed about PDFs, right? So this
catalog.
What?
Product catalogs.
What catalogs?
Product catalogs or menu items, they are typically scanned images or
receipts.
No, but that's not something to be obsessed about.
People can be obsessed about any damn thing. People are obsessed about stickers. What I get there.
But this is kind of my story. I joined Social Corps in New Delhi, India back in 2016 as an intern. It was my final semester of college. One of my tasks was to scrape open data sources, which were primarily PDF reports, for tables, which the analysts could finally use to do analysis, basically. And we worked on extracting tables from, for example, the Indian budget PDFs. We wanted to analyze how the budget was being allocated for different government departments across years. There was another open data source called the National Family Health Survey, which from which we extracted tables like to I guess I forgot the use case for it, but it was another data source. So you remember this? Like a word is simulated by placing some characters closer together, and sentences are simulated by placing words relatively apart. How is a table simulated then? Any guesses? Huh? Just by like placing words like they would appear in a spreadsheet. So like the PDF format doesn't have an internal representation of a table. It's just words and these vector graphics placed at precise xy coordinates relative to the bottom left corner of the page. So like I faced some problems while extracting tables from the PDF sources I mentioned. They're all already there's already an existing ecosystem of PDF table extraction tools. There are some open source ones called which are like Tabular, PDF Plumber, and some closed source tools like which are small PDF tables. Closed source ones are like hosted and they charge a small fee per page to extract tables from a PDF. Uh, so the problems that I faced with these tools was that like Tabular had a really nice user interface, but it either worked or it failed miserably. So there was no in between. It was pretty black and white. Either you will get a good output, or you like you were just stuck with that PDF forever. And the closed source counterparts would work like slightly better, but they costed money. And Tabula was written in Java, and who wants to write Java code, right? um, so yeah, the problems that I faced were like there's no, huh?
That's who want to write dinosaurs.
I guess. So yeah, there's no in between, and like difficult to get complete control over the extraction process. Like you can't tweak any parameters to like finally affect the final result that you're getting.
What is in between? Correct it.
In between you could say like if like something is better than nothing. So like if if you aren't getting it, if you're getting a table with a single column with all the columns squashed together, that is way worse than getting maybe 5 columns if there were 6 columns in the table. So that way. Um, so these problems were not helpful because everything in the like real world, including PDF table extraction, is fuzzy. It's not black and white. A solution that I tried was using PDF to text, which is one of your popular utils that comes installed on Ubuntu and like many Linux systems. So, for example, if this is a PDF table, you could use the layout option for the PDF to text to extract the table into a text file. It would preserve the layout using white spaces, and then you would have to like finally write some custom code, basically split those words based on maybe tabs, or if you're like feeling fancy, you could write fancy regular expressions to extract those words from each row. Yeah, so the output is a text file, and basically the final scripts that you write are not scalable and maintainable because you're doing it for every new type of PDF table. So, like based on the problems I faced while extracting these tables, I wanted something that was in the middle. Like I wanted something where I could tweak some parameters and I would be able to get a better result instead of not getting anything. Uh, so Camelot and Excalibur are like PDF table extraction for humans. These are 2 Python packages that I developed to solve that problem. So this is a snippet of how you can use Camelot to basically read in a PDF. It's a very simple API, just like Pandas. You get a table list. You can export that table list to any format that you want, which can be a CSV, a JSON, HTML, or an Excel file. And you can access each table using indexes. You can do a parsing report for how a table was extracted from a PDF page. It will give you accuracy, white space, how much cells were empty, things like that. And then you can even write a single table to a CSV or any format that you want. And if you want to use that table in your data analysis or ETL workflows, you can just access the table using the .df attribute, which would just give you a pandas data frame. So you remember this table that I showed at the beginning, right? This is a Jupyter notebook where I ran Camelot, and I just read in the PDF file, and I got the data frame, which preserved like the table layout very nicely. So why Camelot? Like I mentioned, I wanted something in between. So with Camelot, you are in control. You can tweak some parameters to affect how a table gets extracted. Bad tables can be like discarded using the parsing report. Each table is a pandas data frame. There are multiple formats you can export your data to. And
how much of is it false positive versus false negative?
So I haven't really tested that right now. It was just a manual thing that I did. I don't have a data set right now.
You run it for thousands of PDF files. It is able to identify 90% correct, but 5% false positive. That is identified.
I have yet to do that. So there's an international conference on document analysis and recognition, which has published a data set you can use to do this. Like I have yet to do. And there's a command line interface.
There you are assuming that PDF file is really a source controlled converted PDF file versus the image which is converted into the PDF file. Like I can take an image which is having
so
a table.
That was something I was coming to. Right now, Camelot only works on text-based PDFs, okay. Not on images.
You need a OCR to do that.
Yeah, so that was something I was coming to. So like you guys would be like wondering why name it Camelot. So I showed you that initial memo. It was called the Camelot project, and I named it after it. And also a fun fact, Camelot is the name of a castle in the British comedy film Monty Python and the Holy Grail, in the Arthurian legend depicted in the film. Another fun fact, the Python package index was called the cheese shop as a reference to the Monty Python cheese shop sketch. I really recommend Monty Python's Flying Circus in the movies. You should really watch it. There are a lot of references riddled throughout Python, like to Monty Python. So you can install it using a simple pip install camelot-py. I've done a comparison with other open source PDF extraction libraries and tools on the GitHub repo, and you can check it out. So how it works? There are basically two parsing flavors you can choose from. So either a PDF table would have a table which is constructed using lines, or all the words are just arranged in a spreadsheet format without any lines. So you can use the lattice flavor to detect a line table and stream to detect a white space table. You can find more details about how it works on this link.
So is it also separate tables? So there are a lot of PDF reports where there's text content and then there's a PDF table. Then there's a table content. So will it give me the text content as well as the table, or will it be able to identify that this is a tabular table?
So it would be able to identify if it's a tabular table in most cases. So with Lattice, the table definition is pretty clear. You know what the table boundary is. So Lattice works 100% of the time. For Stream, I've implemented an algorithm from a paper by Ansi Nurminen. It's called the Nurminen's algorithm, which was already implemented inside Tabula. And sometimes it might give false positives with the content that is not a table. And then there's Excalibur. So Camelot was a Python library, and Excalibur is a web interface built on top of Camelot. You can just run Excalibur using the command Excalibur web server and just go to localhost 5000 and you can upload a PDF onto the interface. You can also see previous uploads. You can either auto-detect tables on the interface, or you can draw table areas and columns to exactly pinpoint a table in the case like you mentioned, like if it's giving out false positives.
So that is given the option of assisted extraction also.
Yeah. And then you can download that, you can view that table on the interface and download it in any format that you want. The formats that I mentioned earlier. So again, you might be wondering why I named it Excalibur. So it's to follow the same Arthurian theme, I named it after Excalibur, the legendary sword of King Arthur. Here's another fun fact. The meta-syntactic variables in Python, the documentation are called spam and x instead of the conventional foo and bar, which is a reference to the Monty Python spam sketch. You should check it out. You can install Excalibur using a normal pip install.
But how spam and X go together? Sperm and go together better.
You have to watch the you have to watch the sketch to.
I have a question. So how exactly is this better than what tools we have? Like they have call outs and stats and such and results. Why is it better? How is it?
So I didn't show you the advanced usage because I didn't have time yesterday to put in those slides. But like I mentioned, other tools like Camelot would give you either a very nice output or they would fail miserably. You can't do anything if they fail miserably. But in Camelot, you can tweak, like for example, say the image, how an image should be thresholded to detect those lines, those kind of parameters.
So are you saying that there is original parsing over here, or are you saying that you are allowing existing parsing body of work that is out there to be counted?
No, so I'm like at the core I'm using PDF Miner, which is an existing library which just gives you the text out of a PDF. But then I've like implemented some heuristics, the lattice and stream that I mentioned, to like for example, if you use lattice, Camelot would try to like threshold the image and finally do some line detection to create that table structure. And in Steam, there's the algorithm that I mentioned. So I just then, like when I have a final table representation from these heuristics, I assign those text strings that I got from PDF Finder into the table sets.
And for line detection, what type of image processing you are using?
I'm using OpenCV.
OpenCV.
Yeah. So there's an algorithm called the morphological transform inside OpenCV. Like we can discuss it offline.
That allows to get you the black and white line.
Yeah, the exact lines on a page. So, since I mentioned I didn't had any advanced slides, so there are like other options for you to like choose. Like you can flag a superscript and a subscript inside like a string. For example, if you had a string inside a column that said 1000 and there was a superscript of 1. PDF Miner would just give you 1001, which would like basically fudge your results. But like if you choose to flag that, Camelot will flag that for you as a separate, like in a separate tag. So like they are basic utilities built into the library like this. So this is the road ahead. I still have to implement an auto detection thing where like you don't have to specify any flavor. Camelot automatically detects what flavor to use. I have to add OCR to extract tablet data from images because right now it only works on text-based PDFs. And like a lot of open data is still trapped inside images. And so it would be just like a Google Lens kind of a thing for PDFs, or PDF tables. And they are like still optimizations for speed needed. In, like you saw, the UI was very primitive since I'm not a front-end developer, so I have to improve that. Like if any of you want to contribute, you can just check out these repos. One is like the first one is for Camelot and the second one is for Excalibur. In there are open issues there. You can use the libraries, open your own issues, submit pull requests. Your contribution would be welcome. So yeah, that was it. It was a pretty short talk after 2 1 talks. Thank you.
Just to add a postscript to this thing, I've done PDF extraction before Camelot, after Camelot, so I've used this multiple instances. It actually helps in setting up the initial, starting point much easier. So if you do not have, okay, when we didn't have Camelot or PDF Miner comes with a different version, PyPDF comes with a different version, and you have to write a lot of rejects, and that breaks in a lot of different PDFs. But this actually helps. So thank you very much.
Can you put the repos?
Yeah. Also, do you have any questions?
How did you check the accuracy by parsing?
Like PDF Finder would give you the text box that a string lies in, the exact text box, and I would like do those like run those heuristics and get the table the coordinates of the table, then I would have the coordinates for each cell. So the accuracy is based on how how that text strings text box overlaps with each cell. So like if it lies more outside, it's less of an accuracy. Like that was something I just came up with for the first version, but like you can propose something better.
What are the performance numbers
Like what?
on how large an Excel does it take? How long?
Uh,
Excels of media.
so like
We called out optimizations in this previous problem.
yeah. So like for a thing like Steam is pretty quick because it doesn't have to do those like that image recognition. It just uses the text strings and tries to guess the table structure. But since Lattice does that image recognition, it takes around 3 seconds per page to do that. So yeah, that is a bit. Any other questions?
If the table inside a PDF as an image,
What?
when you read the table in a PDF as an image,
What do you mean by that?
like you said you use OpenCV to parse the. So is that an image or?
So the first step is to convert that PDF page into an image and then pass that into OpenCV. Yeah.
He hasn't explained it. We just spoke about it.
Or the entire text also gets converted.
Yeah.